Kia ora team, this is Mr. Dharma, and I thought today I'd continue talking about reverse chain rule and do a few more examples. So the first example I want to try is an exponential. So consider this. So if we look on the inside, the derivative of the inside is e to the x, and that's on the outside. So I can use reverse chain rule. So we can just write e to the x plus 5 to the power of 3, add 1 to the power, divide by the new power, divide by the derivative of the inside, that cancels, plus c, and so you're left with your answer. That's not the only place you can do that. You can even do that on slightly simpler questions. 10 e to the x plus 5 dx. If you wanted to, you could expand. And that's probably what I would do. But if you didn't want to, you can notice that the derivative of the inside is e to the x. The 10 doesn't matter, so I'll write it out the front. And so I can take this and I can go add 1 to the power, divide by the new power, divide by the derivative of the inside, boom, boom, plus c. And that works just as well. And if you were to expand, you would notice the same thing. That's because this is how integration works. Shall we try that with a different question? What about this? The integral of 18 e to the x square root e to the x plus 2 dx. Well, first off, you'd write the square root as e to the x plus 2 to the power of half dx. And then you'd notice that the derivative of the inside is e to the x. The 18, once again, you can write out the front. And the derivative of the inside is on the outside. So it's 18 e to the x plus 2 to the power of add 1 to the power, divide by the new power, divide by the derivative of the inside, plus c. Cancel, cancel. So you could simplify this in whatever way you want, and you will get 12e to the x plus 2 to the 3 over 2 plus c. But the matter is that the maths still holds quite nicely. Alright, so what else can we do with this kind of stuff? Well, let's have a look at this other example. What about if I had 2x plus 7 over x squared plus 7x? Right? This is a very similar question, okay? Because I can see it as 2x plus 7 times 1 over x squared plus 7x dx. And once again, 1 over integrates to log, or ln, but if you notice the derivative of the inside is multiplied at the front. And so I could integrate this to 2x plus 7 ln, and then I divide by the derivative of the inside. These cancel, plus c. And so another way of looking at this is if the derivative of the bottom is on the top, then the integral is ln the bottom. Okay, and this is also on your formula sheet, plus c. So let's try another one of these. What about 3x squared plus 8x over x cubed plus 4x squared dx? Notice that the top is the derivative of the bottom, so I can just write ln x cubed plus 4x squared plus c. Sometimes it's not as obvious. What about 6x squared plus 16x over x cubed plus 4x squared dx. You notice that if you factor a 2 out, you will get what you wanted. You will get the top as the derivative of the bottom, so the answer is just 2 ln x cubed plus 4x squared plus c. Right? I hope this helps. So there's two ideas here. If the top is the derivative of the bottom, it's just ln the bottom plus c. And we also did some more of the reverse chain rule using exponentials. All the best. If you need help, just sing out.